Hello my dear friends. So today we are going to solve the rod cutting problem. So I will tell you the problem statement. So in this question the length of the rod is given. So here the length of rod is 8. Okay. And a length array is given and a price array is given. So what we have to do is, suppose a rod is given of the length 8, right? We need to cut this rod into smaller pieces, okay, into smaller pieces, and we have to see in which section we should cut it so that we can get a maximum profit. For example, if we cut in the length of 4 meter and 4 meters, so this is the price for 1, this is for 2, this is for 3, this is for 4, 5, 6, 7, 8. So for 4 price will be 9. So here we are going to get 9 rupees, here also we are going to get 9 rupees. So what we are going to get, we are going to get total as 18 rupees. Perfect. Suppose if you are not going to cut this rod and if you are going to sell the complete rod of length 8 meter, so what is the price of 8 meter? Rupees 20. So this rod will be sold in the 20 rupees. But here if you are going to break this rod into 4 and 4, okay, you are going to get 18 rupees. So ultimately what is our task? Our task is to maximize this profit. Okay, for now we have taken 2 cases. Let us take other cases. Okay, what we are going to do, we are going to cut this in the length of 1 is 2 and 1 is 6. Now total length is 8. So what is the price of 2? Price of 2 is 5 rupees and price of 6 is 17 rupees. So if you are going to add them, what you are going to get? 22 rupees. So now the profit is maximum than the rest 2 cases. So we have to maximize the profit. I hope the question is clear. You can cut into any pieces. It doesn't mean that you can cut into 2 pieces only. You can cut into length of 1. Okay, suppose you have cut this in the 1 1 1 1 and other one is 4. Now total length is again 8. So what is the price of 1? 1 rupees. So 1 2 3 4. What is the price of 4? 9 rupees. So what you are going to get? You are going to get 13 rupees. So ultimately you can cut this rod into any number of size. Okay, any number of size, 1 2 3 4 5 6 7 8. Okay, so I hope the question is clear now. Now let's see how we are going to approach this problem. So what was given in the question? The length array was given. Okay, what was the length array? If suppose n is equal to 8 is given, so length array will contain the values up to 8, right? And what is the price array? Price array is having the prices of all the lengths. So 1, 5, 8, 9, 10, 17, 17 and 20. This is the price array, right? So now let us see how we can approach this problem, right? So what we have to do, suppose this is the length of the array. Perfect, this is of size 8, right? So here what we are going to do, first of all we are going to take the decision on this element 8. Okay, we can break into like 8 this. So here we have 2 choices, either we can break it or we can leave it. It means we can break this length into 8 or we can leave this length into, we are not going to break it. Okay, so here I want to teach you one concept of knapsack, unbounded knapsack, and this problem is the unbounded knapsack. So what happens in unbounded knapsack is, suppose if an array is given, okay, with the length 1 2 3 4 5 and 6. So here you can take the 6, you can leave the 6. Okay, this is the concept of 0 1 knapsack. Either you can select it or you can leave it. But if you have ignored it, it means this item is processed. Now you are not going to take any decision on this item. Okay, first of all I am explaining you the 0 1 knapsack. So if you have taken the decision that this item should not be included, so processing is done. Here I am writing processing and it is done. And if you are going to select this element, then also processing is done. This is in 01 knapsack. Okay, it means once you are going to take decision on this element, then we are not going to come back again on this element. What we will do, we will take the decision on the 5th. This was the 01 knapsack. Now let me tell you about the unbounded knapsack. Unbounded. So what is the difference between these two? Suppose the array is given 1, 2, 3, 4, 5 and 6. Suppose if you have, here also we have two choices, either take it or leave it. Correct? So if you have taken that I am not going to take 6, it means processing is done. It means processing is done. But if you have taken the decision that I can take 6, it means you can again process. Okay, again we can process this. I will tell you how again process. If you have taken the decision that yes, I can take this, so processing is not done. But if you have taken the decision that I am not going to take it, it means it's the final decision. You can take an example like this. Suppose this 6 is a task that eat non-veg, eat mutton. And suppose if you are a vegetarian. So if you are a vegetarian, are you going to eat mutton? No. And this is done. Means you are taken final. It's final decision that yes, I am not going to eat mutton. Okay. But if this is paneer and you are vegetarian, so you can eat paneer once, you can eat paneer twice, you can eat paneer thrice. Whatever number of time you want to eat paneer, you can eat the paneer. It means here the processing is going on. Means you can eat paneer up to your wish. But if it is mutton here and you are a vegetarian, then you have taken the decision that no, I am not going to take it, I am not going to have it, so processing is done here. Correct? So now I will tell you how this problem is related to the unbounded knapsack. So one length was given of 8. Okay. So what we were doing, we can break this into the pieces and the pieces size can repeat like 1, 1 and 6. It means if you are going to select it, then the number of times you are going to select is not fixed. It's completely depend upon your choice. Right? Here also I told you, if you want to eat paneer, you can process it again and again. So similarly, if you are going to break this road to the different length, so you can choose one many times. Okay, you can take the decision on one many times. Okay, so here you will get 1 rupees, 1 rupees. And what was the price of 6? The price of 6 was, I think it was 17. So what is the profit you are going to get? Here you are going to get 19 rupees. Right? So here I just want to take your focus to one point, that if you have taken decision that we should take this element 1, we should take this element 1, so you can again come and take the decision on this, either you want to take 1 or not. Okay, it's completely free that you can again choose a element that you have already taken the decision. But here we have not broken this in the size of 2, 3, 4, 5, 7, 8. So here you told that I don't want to break this road into this size. So you have taken the decision, now you are not coming on the decision. But you have told that I can break this road in the size of 1 and 6. So you can choose 1 many times and you can choose 6 many times as per your requirement. Got it? Got my point? I just want to clear the concept. So what we were doing in the knapsack? In knapsack, what we were doing, we were first writing the, I am telling about the recursive solution, then we will move on the dynamic programming solution. Right? So the price array I am talking about, price array was given and length array is also given. So what is the price array? Price array was like this: 1, 5, 8, 9, 10, 17, 17 and 20. This is the price array and this is the length array. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So in recursive solution, what we were doing, first of all we need to check the base conditions. Okay, so first of all we need to take the decision on this, then we need to take decision. Once the decision is over on every element, then we should return the solution. It means if n equal to 0, if there is the length of the rod becomes 0, means you have taken the decision on every element, what you are going to do, return 0. Or you can think like this, if the size of rod is 0, what is the profit you are going to get? No profit, my dear friend, no profit we are going to get. It means if n is equal to 0, we are going to get 0, right? And what is the maximum length of this rod? Maximum length of the rod is 8, right? What is the maximum length of the rod? Maximum length of the rod is 8. Suppose if you choose that I want to break this rod, in the size of 6. Okay, if the size of if you have taken the decision that I will take 6, now what is the required length? That 6 is already done, now the required length is 2. So the maximum length now become 2, because 6 is already taken, now maximum length is 2. So you need to take decision on this 2, right? So maximum length is also changing. And if maximum length will become 0, then what you are going to get? Anything? No. So if n is equal to 0 or max length equal to 0, then return 0. Oh, you can use or like this. This is the syntax of Python and this is for C++ and Java, right? So this is done. This is the base condition. I am telling you the recursive solution. So in recursive solution, we want base condition and choice diagram. So choice diagram, I explained you that we have two choices, either select it or leave it. But if we leave it, processing is done. But if we select it, processing is on, we can again process. Okay, this was the choice diagram. I will again make the choice diagram. So what was that? 1, 2, 3, 4, 5, 6. We have two choices, either take it or leave it. If we are going to leave it, then processing is done. But if you are going to select it, we can again process. So we need to write the code for this. And in recursive solution, we know that we always start from the last, then we come one step backward like this. Okay, so now what we have to do? Now we have to take the decision on the 6th element. So if length of n minus 1, so first of all there is one tricky not tricky one, you can say like this. Suppose here the length is given as 10 and you want to cut it into only the 8. So are you going to take the length 10? No. If the element, this length array, if this length array element is greater than the maximum length, okay, maximum length is fixed. So if it is greater, we are going to leave it. But if it is less, then we are going to take the decision, either select it or leave it. So here, if the element, if this 6 is less than 8, okay, so you have two choices. What are the choices? That tn comma max length, sorry, we were writing the recursive solution. So in recursive solution, what we are going to do, we are going to call the function. Suppose this is rod cutting function. So rod cutting function. So what we are going to do, either we are going to take it or we are going to leave it. So first of all, I am going to write the code for leave it. Okay, so leave it means now we have taken the decision on this element. Now we need to take, now the length of array will be decrease. Suppose here the size of length is n, length of array will be decrease here, because we have already taken the decision, right? So it will be like this. rod cut, price of array, length of array will be same, maximum length is also same because we are not taking that element. So maximum length will be same, but the number of elements in the array are decreased now. Okay, price array is same, length array is same, maximum length is same, but the number of elements are decreased because we have told that we are not going to take this element. Are you getting my point, what I want to say? I hope you got it, right? Or we are going to call this rod cut function again. But and again we are going to send this price and length array. But if we are selecting this, so the maximum length will decrease. So it will be max length minus this length of n minus 1. Okay, if you have maximum length is 8 and if you have taken the decision that we should take 6, so now maximum length will become 2. It is max length minus length of n minus 1. And now tell me that we have chosen that 6 should come. So we can again process this. So the size of array will decrease or not? No, it will not decrease. Right? The size of array will not decrease. So here it will be n only because we can again process this. But here we are not going to process this. Suppose if you have chosen the length, so you should also add the price of this 6. You have chosen this 6. So in profit you should add the prices. Okay. So what we are going to do? We are going to add the price of n minus 1. Means we are going to add the price of that selected piece. Okay. And we are going to take maximum of both of this. Are you going to get what I am saying? Okay. So either this, we can take this or this. Whichever will give us maximum profit, we are going to take that one. I am just trying to explain you the concept. Clear code we are going to write at the end. Okay. Else. In else part, what it will come? That we have, if this, suppose here the length is 10. They are saying to break into the length of 10. So are you going to take 10? You are sure that how can I break a rod of 8 meter into 10 meter? No, we are not going to take. So finally what we are going to do? We are going to write like this, that again we are going to call rod cut function. We are going to ask price array, length array. Maximum length will be same as it is because we have taken the decision, but the number of elements will decrease. It will be n minus 1. So this is the, I can say, the logic of choice diagram. Are you getting what I want to say? Now let us write the DP solution. It is very easy. So what happens in the DP solution? In the dynamic programming solution, we are going to make a array. Okay, DP array of size of n plus 1 and n plus 1, maximum length plus 1, that is also n. Okay, and we are going to start every element with the 0. So you can write like this: for int I is equal to 0, I is less than equal to n, I plus plus. For int j is equal to 0, j is less than equal to n, j plus plus. And here I am going to write if I equal to 0 or j equal to 0. So we are going to fill this dp I comma j with 0, right? So in this step what we have done? We have filled the entire dp with the 0. Okay. Now what we need to do? We are going to apply the same condition. That in this only I am going to write. Okay. This is the first condition that we have done. If I is greater than j. If I is greater than j means if the division length that we are doing, that is greater than the required length, that 10 is greater than 8, this situation is this. So are you going to take this 10? No. So what we are going to do, dp I comma j will be, we are going to move one step backward. So I minus 1 comma j. I is n and j is the price. You can think like this. So I minus 1 comma j. Okay, so first of all we need to check this. Then we are going to check, else we will come into this block. Then we are going to take if this is greater or if it is smaller. Then what we are going to do, we are going to write dp I comma j. Either select it or leave it. So if you are going to leave it, so it will be dp I minus 1 comma j. Simple, right? But if you are going to select it, I minus 1 means we are going to take decision on the one step back. But if you are going to select it, so it will be I only, because we can again come and take decision here. And now maximum length will be reduced. So j minus, what was that? J minus I, right? The maximum length will be j minus I. Okay. And what we need to do, we need to add the price also. Okay. So price of I minus 1. Correct. And then what we have to do, we have to take the maximum of this. So this will form the entire dp, and at the end what we are going to do, we are going to return dp of n comma n. Okay, so I hope you got it. What we have done, first of all we have tried to relate this question to the knapsack problem. Then we have done the solution. So I am attaching the GFG link in the description box, so you can go through their solution also. Method is same, but they have written the code in the structured way. Then you will get that also. Okay, thank you.